So the product is riceable waste concrete panels for the precast civil structures. So can you please move on to next slide? So you can see the stubble burning is a problem, and we don't need to give you much introduction to. Okay, okay. To the issue, just we have shown two snapshots over there. One is stubble burning in an open field, and second is an image from the NASA satellite that it's a prevalent problem, and this year we are already into this problem. And if you can see, the bottom right figure out there, 1,027 incidents are already observed this year, which are far more than the number of incidents observed in 2022 and 2021. So yeah, this is a prevailing problem, and many solutions have already been proposed to alternately utilize the stubble waste, like the one you can see is the cutlery, biodegradable, and then rice straw briquettes, paper, cardboard. Okay, these are some conventional practices which are already adopted. But what we think that this problem can be resolved by the adopting a multi-pronged approach. So what we want to show you here is that like this is a wall masonry structure. You can see the EPS panels, which are quite conventionally adopted now in for the rapid construction technologies. So on figure on left hand side shows you an EPS panel, like it is a structure of this shape. You have a wire mesh on both the sides, and then you have a EPS expanded polystyrene material in between. So these are panels which are widely adopted mainly in the Bangalore region, and now they are also coming to the North India establishments as well. So what we want to replace this EPS, because this EPS, as we know, is an environmentally hazardous material, and you can see several associated hazards with this material. One is health impact, then second is this processing of this EPS board itself is a, you can say, carbon intensive process, and a lot of greenhouse gases gets generated. So there are recycling challenges to this component as well. So like many countries have already banned the EPS panel, EPS in fact, from many of the applications. So what we have proposed, we have proposed to replace the EPS with the widely available straw that we have in abundance in our region. So that's the board that we have proposed. One board is kept over there. So like prior to the like this project is already granted to us by the DST, and so I would like to just present you some results which we have already achieved. The testing has already been done at the straw level as well as at the board level. So we were able to achieve the strength about 47 MPa, and which is much higher than the EPS strength, because EPS is a brittle material and it doesn't have a good tensile or 3-point bending strength. Apart from that, it also provides good thermal insulation if it is a middle layer, and you can do concreting on the other two sides. So this layer will act as a barrier from the inside heat to the outside. So it in fact has the stubble board has the insulation which is about 0.03 watt per meter Kelvin, and it is just 1/100th of the conductivity of the concrete. So that's one of the property. Then we are also analyzing it for the biodegradability as well. We have already done some kind of treatment of this stubble waste with alkalis and with the water treatment, and what we were able to achieve, that we were able to reduce the cellulose content, which is little biodegradable, but with the help of the pre-treatment, we would be able to in fact counter the issue as well. So if we do the cost comparison, then conventional EPS board, which is deployed in the structure, it comes out at a cost of 550 to 700 per piece. And the size of that board is, you can see 1,000 by 1,000, that means 1 meter by 1 meter. And the thickness of the board is 50 mm. So we have done a rough cost estimate of the product that we have already created. So the cost comes out to be 375 to 400 per piece, and that is because we just created one product on the lab scale. But if we are going to in fact create it on the mass scale, then obviously the cost may come down further. So we are sure that we may be able to achieve the same panel of the same thickness or properties at a cost of just 50% of the one which is already available. So this is the technology that we are offering today, and We have also done some kind of testing as well. Like the boards were prepared using different kind of binders, and we were able to, in fact, test different type of binders, and the one with the lowest cost has already been found. And further, the concreting was done, and then we have done some kind of compression test as well and 3-point bending test as well. So the results are quite promising at this moment. And then further, the figure on left-hand side at the top shows the thermal conductivity tests which have been done on the panels, and then few stages of the fabrication of the boards. IPR has been filed, and TRL level is 6 pre-commercialization. So in order to commercialize this technology, we in fact need to develop these boards using some kind of equipment which should be there, which can produce these boards at a faster pace. So we have also got one research project recently through which we will be developing one equipment on which we can process these boards, we can do the compression, and we can do the stitching of the boards simultaneously and do the binding of these boards on that machine. So this is a work in progress. And then further, we may need some kind of funding today, because we need to have a housing prototype like the one which has already been showed by Dr. Pankaj in his last project, that they have created a housing prototype and they have tested it for different kind of scenarios. So we may need that kind of setup today in the coming future. So yes, tie up with the industry would be can be done preferably in the area of EPS. There are many companies which I have shown out there, just a list of few, which are already manufacturing these boards, but these are the EPS boards. So what we would like to replace these with the Stubble boards. So yes, there is a wide potential out there. A number of companies are already in market, and this field is up for the grabbing. The target customers, what we see that initially this product can be sold for the commercial establishments like the buildings, malls, or like the theaters. But yes, if this technology has to be adopted at the household level, then obviously there would be a change of mindset, because conventionally people are still adopting the brick technology for the construction work. So, but we can see just a rough estimate is that around 40% of market still we can catch with this product, because it is already out there. So yes, tier level to achieve tier level 9, we may need a time of 1 year, because we have to do some kind of testing as well on a prototype building. So if you see this figure, then we have already created one building at TAT Patiala, but this building was created using the EPS panels with the expanded polystyrene material, and we would like to create the same structure now with the Stubble boards, and try to check the efficacy of these boards under the given conditions. So we may need some kind of equipment as well, and then some kind of construction masonry as well. So we have requested some funds through this call, and then this last slide is just to show you the terms and conditions of transfer of technology. So that's all from my side. If you have any questions, you can ask, and you can also ask Professor Quatra as well.